Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Small Giants by Kafka Farnham. And here are the rules. We have chaos construction rules where we need to divide the grid into 5 regions, each made of 5 orthogonally connected cells. So what is an orthogonally connected cell or orthogonally connected region made of 5 orthogonally connected cells? That means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region. This, however, is not, because even though these two cells can go to each other by going through edges while staying within the region, they can't go to any of the other cells in the region by just going through edges while staying within the region. They either have to go through a corner or exit the region by going through edges, but neither of those are allowed for an orthogonally connected region. And that's how orthogonally connected regions work. The regions and the grid as a whole must follow the doppelganger rules as described below. And every region must contain a doubler cell. Okay. So, okay, he does explain doppelgangers. Okay. We'll explain that later. The digit in the top left cell of a region, that is its leftmost cell in its highest row, is the region number. And all region numbers must be different, and together they must form a set of the digits 1 through 5. Oh, 1 through 5, right. Okay, so because, yeah, this is doppelganger. I keep forgetting about that. So, the leftmost digit, the digit in the top left cell of a region, which is the leftmost cell in its highest row, is its region number. And it has to be unique, and they have to form a set of the digits 1 through 5. So in this region that we constructed, where is the region number? It has to be the leftmost cell of its highest row. This is its highest row, so the leftmost cell would be here. So this digit would be the region number if this was the correct region. And it can't be 0, because it could be 0 in doppelganger, but it can't be 0 here. Okay, let's get to the doppelganger rules. Every row, column, and region contains the digits 0 always, as well as 4 out of the 5 digits from 1 to 5. That is, it's missing one digit that is not 0. No 2 rows, 2 columns, or 2 regions may be missing the same digit. And for each 0 in the grid, the digits missing in its row, its column, and its box, its region, must be 3 different digits. Yet zeros always have a null value. That is 0. Okay? So again, every row, column, and region is going to be missing a digit 0. Has to have a digit 0, but it's missing a digit from 1 through 5. However, no 2 rows can be missing the same digit, no 2 columns can be missing the same digit, and no 2 regions can be missing the same digit. Also, for each 0 in the grid, the digit that's missing for its row and its column and its region have to be different. And the 0 always has a null value, or that is 0. So say we had a 0 here. That means, actually, let's have a 0 here. That would mean in its row, it has to be missing a different digit than the digits it's missing in its column, which must be a different digit that it's missing from its region. So that's typical doppelganger rule set. We have doublers, where every row, column, and region must contain a doubler cell that will double the value of its digit. And these 5 cells also must form a set of the digits 1 to 5, such that a doubler cell cannot contain a 0. And doublers also cannot also be region numbers. So they can't be the leftmost cell of the topmost row of any region. Right, and what are these doublers used for? They are used for region sum lines, where the region borders must divide the blue lines into segments that each must have the same sum. If a line exits a region and re-enters it elsewhere, these segments are to be counted separately. And every line needs to be divided in at least 2 segments. And every line must have at least 1 region number on it. Okay, so that's an interesting rule. So, okay. Say this was a valid region. Then these 2 cells, well, first of all, every 2-length line still has to be divided, has to have a region between them, because each line must be divided into at least 2 segments, right? This would be an example of 3 segments, but basically the sum of the value of the cell here must equal the sum of the value here, which must equal the sum of the value here. So that tells you some information, assuming that this region would be valid. It's probably not valid. Well, it could be, I guess. Technically. Anyways, that's how region sum lines work. And remember, each line has to contain at least 1 region number, which is the leftmost cell of the topmost row of a region. So that means each of these lines must have a region number on it, which means all 5 region numbers are on these lines, interestingly enough. Huh. Okay, so those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We know region sum lines must be divided into different regions. There must be some regions. So this cannot be all 5 there, because that would be the same region. This is going to be a region number. So it must be 1 through 5. And you cannot have a doubler on the region number. So this is not going to be a doubler. So this is not a doubler. Doublers will have as red, I guess, and the non-doublers are blue. This is going to be... Okay, so this has to be a region number also. If it's not, how would it not be a region number? Is if it goes something like this, but then this would be too large of a region. So this has to be a region number also, which means that's not a doubler, and it's not a 0 through 5. There has to be one of these 2 is going to be, so this is the region number here. I guess maybe we should have the region numbers be green. So the region numbers are definitely these 2. So there cannot be another region number here. There's a region number either here or here. If this were a region number... Okay, if this were a region number, there's no other way that this would have to also be a region number, and we have too few then region numbers because each line has to have a region number. Sorry, we would have too many region numbers. So this cannot be a region number. If this is, again, if this is a region number, it's the leftmost of the topmost cell of a region. But then the problem is this is never going to get past it to get to another top row. So this would have to be the top row of another region, or the leftmost cell of the top row of the region. So no matter what, this can't be a region number, which means this is a region number here. One of these is a region number. One of these two is a region number. We need a region that will go to here, right? And none of these currently can access that. So whatever region goes here has to be essentially the region number here. So this is going to be 1, 2, 3, 4, or 1, 2, 3, 4, or 1, 2, 3, 5, 4, 5. Either way, this is going to have to go out somewhere. So this region has to go either here or here or here. Therefore, these are part of the same region. So there's no border there. These have to have doublers. These are values of 1 through 5, and they sum up to the same sum as this. And the region numbers can never be doublers. So this has to be a doubler here. This must be doubler here because it can't be the same digit here. So this is doubler, which means no doublers here, no doublers here. Also, these can't be region numbers either. This could be. Well, using blue as non-doublers. What do we use as non-region numbers? Yellow? Well, okay, these are non-region numbers. One of these two is. This is not a region number because it's a doubler. So because of that, it has to go either to here as its region number or to here as its region number. So these region numbers must be doubled. So this has to be then 2 and 4, which means this has to be 1 and 2 for the doubler. Obviously these can't be doubled. Here. This can't be doubled. This can't be. It should be blue. Oops. So this is blue, blue, and blue. This cannot be 0. Neither of these are doubled. So they cannot be 0 because one of them is going to be a region number. So therefore this must be 0 here. So this is a 0, which cannot be a region number. These have to add up to the same sum. One of them is a region number, so 0 is going to be 0. Therefore, this cannot be a region number. One of these two is the region number. 0 we'll label as pink, I guess. And it cannot be the region number. So region number is one of those two, region number is one of those two. So this has to be part of this region here, because it can't be part of any other region here. Otherwise, it would be a region number. So then this is not a boundary. So we have 3 cells here that are the same region. Okay. These must be the same value. These must be the same value. So this is 0, which means none of the rest can be 0. 0 cannot be here. 0 is one of these two. So we have 0 being one of those two. 0 can't be here. 0 has to be one of those 3. 0 can't be here. 0 is one of those 3. Where is 0 in... Oh, 0 could be here, technically. Okay, 0 is one of those 3. 0 can be any of those 4. So there's that, too. This cannot be 2 or 4. It cannot be 1 or 2. This has to be 3 or 5 here. Because we know this is going to be one pair of 1 and 2, or 2 and 4. This has to be the other pair, because we can't have repeats within the region numbers and the doublers. This can't be a region. This can't be different regions, I should say. 0 and then another digit is never going to be adding up to 0, with one of these being a region sum. So therefore, this is not a boundary. So we have 4 digits here, which are all the same region. This is the leftmost of this region here. So this has to be the same region. So there's no boundary there, which means there is a boundary here. There is a boundary here. This has to go out somewhere. It has to go out there. So that's done as a region. This can't be a region border. Wait. Oh, I guess this could... Okay, so that's not going to work. So if we try to have that as a region, this goes out that way. But that's not going to work. So therefore, this must go out this way. So this has to go that way. How does this work? So there has to be a border between these two. This then would... Okay, so if there's a boundary between... If this is not part of the region of this, that means it's part of the region here, but then this has to go out here, and this is going to be the leftmost of the topmost row. So this cannot be going out this way. It has to go out this way, because these are 2 separate regions guaranteed. So therefore, this is a region border there. And it cannot go out. So if we try to go out here, that's not going to work, because this is not going to be a full region then. So this must be part of this region here, which means this is a region number. So that's a region number. This can't be a region number, so this must be a region number here, which means it cannot be 0. So we have all the region numbers here. Okay, we don't need yellows anymore because yellows are the non-region numbers. Now we have doublers. These have to be 1, 3, and 5. Oops, not 1, 6, 8. 1, 3, 5. Because we have a 2, 4 already accounted for. There's no boundary between those two. This is a boundary. So this has to be, well, it can't be doubled. So it has to be at least 3. So this is 3, 4, 5. This could potentially be, oh, this is 1, 3, or 5, which means this cannot be doubled. So we have no doubler here, which means the double, and this can't be 0 because of 0 in the box, so this must be the doubler here, which means this can't be doubled, these can't be doubled. So this is the same as this plus potentially another digit. This cannot be 1 or 2. It's 3, 4, or 5 here. This is non-doubled. This is non-doubled. So this has to be 1, 3, or 5, adding up to the same sum as that. These cannot be part of this region. And they can't be part of this region because that's a region number there. So this must be a full region here. This cannot be part of this region or this region because it's the leftmost cell of this row except for that. So this has to be the same region there, which means this is boundary there. This has to go down here. So this must be a full region this way. And this could be 5 going this way or 5 going this way. We're not sure. If it went this way, so say we had boundary there, then these 3 digits would have to be essentially the same sum. But there's no doubler here, which means these would have to be the same digit, so that doesn't work. So this must be the boundary that way. We have a doubler here, which means this cannot be doubler here. Where is the doubler in column 2? It must be here, which means this can't be doubler here. Where's the doubler in row 4? It must be there. So 0 obviously can't be where the doubler is. This is 3, 4, 5. This is 3, 4, 5. This must be the same sum as this. So this is 3, 4, 5. So these are the same digit. You could have 0 here. One of these is 0 here. Where is 0 in column 4? It must be here. So this is 0, which eliminates 0 from being here. So we don't need the blue anymore. These can't be 0. Where is 0 in this lower left-hand region? It has to be here. So this is 0, which means neither of these can be 0. Where is 0 in this left region? It has to be here, which means this can't be 0, which means that's 0. So we have zeros there. It has to be adding up to 3 and 5. So these are 3 or 5, and it's the same digit as this. This digit cannot be here. And these have to be different digits because they cannot be doubled. So where is this digit here? It has to be... Oh, it doesn't have to be in this region. Right. So these 3 digits are the same. So let's mark them as A. So they must be missing from this region here. Okay. So these are all A, because they must add up to the same sum. This cannot be 3, because 0, 1, and 2 would eliminate all possibilities for that cell. So these A has to all be 5. So this is 5, which eliminates 5 in the rest of the row. column, and region. This could be 5. We're missing a 5 in this region here. So this is missing a 5 in this region here because 5 can't be here. This must be either 1, 4 or 2, 3 adding up. Well, this is guaranteed to be 1 or 4 or 2 or 3, which means there's a 1, 3 here. This is guaranteed to be 1 or 3. This can't be 1 or 3. It's 2. 2 doubled is 4, so that's 4 there, which makes this 2 and that 1. This can't be 1. This must be 3 then. So this can't be 2 and 3. It's 1, 4, adding up to 5. 1 eliminates 1 here. So this must be 4, and that's 1. 4 eliminates 4 here. So that's 3 doubled, which makes this 4 doubled, which makes that 5 doubled there. 3 cannot eliminates 3 in the rest of the box here, or the region here. So that's 1, which makes this a 1 to add up to 1. So this 0 is missing a 4 in the row. It's missing a 3 in the region. And it cannot be missing a 3 or 4 here. So therefore, where's the 4 in column 5? It must be there. So that means this region's missing a 2. This column's missing a 2 here. This region cannot be missing a, well, it's not missing a 5. It can't be missing a 2. So therefore, this must be 2 here, which means this region is missing a 4. This region here must be missing a 1 then. Row 2 is missing a 5. Row 3 is missing a 3. Row 4 is missing a 2. Row 5 must be missing a 1. So this has to be, this is missing a 3. This is missing a 4. We must be missing 1 and 5. So we're missing 5 here and 1 here, which means this must be 2, and this has to be a 3. Does that work? So we have leftmost cell of the topmost row. That's correct. That's correct. That's correct. That's correct. That's correct. They must be the set 1 through 5, which they are. Oh, I guess I have to delete these, right? Yeah. Yeah. And that's how you solve it. Fairly straightforward, I guess. Yeah. All the zeros have different values. So this 0 is missing a 5 in the row, 1 in the column. Okay. Let's make sure that we have everything else. Well, we know that we have the answer correct, so I don't know if we, but just as a sanity check, let's make sure we have everything. Region sum lines. We have 1 doubled is equal to 2, which equals equal to 2. 3 is equal to 3. 5 and 0 add up to 5. 0, 1, 4 add up to 5. 5 adds up to 5, and 5 adds up to 5. 1 adds up to 0 and 1. 2 doubled adds up to 4, which is equal to 4. We have a 1 region's number in each of the lines. And they form a set of the digits 1 through 5. The doublers form a set of the digits 1 through 5, and we have 1 in each row, column, and region. We have a 0 in each row, column, and region. This 0 is missing a 4 in the row, 2 in the column, and 3 in the box. This 0 is missing a 5 in the row, 1 in the column, 4 in the box. This 0 is missing a 5 in the region, 4 in the column, and 3 in the box. This 0 is missing a 1 in the region, 5 in the column, and 2 in the row. This 0 is missing a 2 in the region, a 3 in the column, and a 1 in the row. So that's all kosher. Interesting. I love chaos construction puzzles, so this was pretty fun for me. Pretty easy though, also, but that's because I've done quite a bit of chaos construction puzzles, and so 5 by 5 is not going to be that hard for me. And then adding, I've done doublers, I've done doppelganger puzzles too. So yeah, none of these are that hard for me. So anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.